Example 4. Write a possible explicit rule or explicit formula for the nth term of the sequence. So first, let's figure out, well, basically we're writing a function of n. So we need to decide, is it going to be linear, quadratic, or exponential? So we first check the first difference. Well, to get from 5 to 10, you have to add 5. To get from 10 to 20, you have to add 10. 20 to 40, you have to add 20. 40 to 80, you have to add 40. Well, there's no constant first difference, so we know that it's not linear. Now let's check a constant second difference. To get from 5 to 10, you add 5. 10 to 20, you add 10. 20 to 40, you add 20. Well, that means it's not quadratic because it does not have a constant second difference. Now let's check to see if there's a constant ratio. Well, we do 10 over 5, which gets us 2. 20 over 10, which gets us 2. 40 divided by 20, which gets us 2. And then 80 divided by 40, which gets us 2. So, because they are all the same, we can say that it is exponential. So now from here, we have to figure out what would our equation look like. So I'm going to kind of move this up a bit, give us some room. So we got to remember that our first term is 5, our second term is 10, our third term is 20, our fourth term is 40, and the fifth term is 80. So we got to think of an equation to where if we plug 1 in for n, we get 5. We know that the constant ratio is 2. So we have to think about a sub n equals, we know we're going to have 2 to some power of n, and then something else has to happen to it. We'll think about the fact that our first term is 5, so 5 has to be involved. So we're going to have 5 times 2 to the power of, and not just n, but n minus 1. So 5 times 2 to the power of n. And the reason why I know this works is because if we plug 1 in, that means we have 5 times 2 to the power of 1 minus 1. Well, 1 minus 1 is 0, so we have 5 times 2 to the power of 0. Anything to the power of 0 is always 1, which gives us 5. Now if we plug in a sub 2, 5 times 2 to the power of 2 minus 1, which is 5 times 2, which gets us 10, which works. And you can check it by plugging in all the other ones. So we know that our explicit rule is a sub n equals 5 times 2 to the power of n minus 1. Now, you might be wondering, well, how did we know that that was where to start? And, checking to see if it's linear, if it's quadratic, and then if it's exponential. Those are going to be kind of your first few steps. Whenever it's exponential, whatever your ratio is, that's going to be your base for your exponent. Usually then your first term in the sequence is multiplied by your base in the exponent there. From there, you kind of then just have to figure out, well, is it just 2 to the power of n, or is it n minus 1, or n minus 2? That you have to, kind of go through using trial and error and just seeing what works. And eventually you will then find a formula or a rule that will match your sequence. Example 5. Write a possible explicit rule for the nth term of the sequence. Again, we want another explicit rule, so basically a function in terms of n. Let's first check to see if it's linear. So 1.5 to 4 means we're adding 2.5. 4 to 6.5 means you're adding 2.5. 6.5 to 9 means you're adding 2.5. 9 to 11.5 means you're adding 2.5, which we have a constant first difference, which means it is linear. So we have a sub n equals, well, our first term is 1.5 plus, we know we have to add 2.5 every time, but we need to write this in terms of n. So 2.5 times, well, timesing it by just n doesn't work because I know that my first term needs to be just 1.5, meaning I'm not adding or subtracting anything to it. So we're going to do it n minus 1. Because if we then plug in 1 to find our first term, that means we're doing 1.5 plus 0, which is 1.5. Now, to find our second term, let's see if it matches up. And I'm going to kind of do this off to the side here. If we have a sub 2, that means we're doing 1.5 plus 2.5 times 2 minus 1. Well, that's 1.5. 2 minus 1 is 1, so it's just 1.5 plus 2.5, which gets us 4. Plugging in a sub 3, that's 1.5 plus 2.5 times 3 minus 1, which is 1.5 plus 2.5 times 2, which gets us 6.5, which works. And you can go through and check it for each one as well, and kind of confirm that this is indeed our formula. Now from here, I'm going to clean it up a little because we have some parentheses and stuff going on. So I'm going to distribute the 2.5 into the parentheses, giving me 1.5 plus 2.5n minus 2.5. We have some like terms here, 1.5 minus 2.5, so I'm going to combine them, giving me 2.5n minus 1, and that is then our simplified explicit rule. A sub n equals 2.5n minus 1. And that concludes our lesson on 9.1.